Okay, so we're about to dive into this incredible, hidden environmental superpower. And it's not happening in some fancy high-tech lab. Nope, it's right under our feet, in a place you'd probably never expect. Just a simple, grassy pasture.
I mean, it sounds almost too simple to be true, right? What if the solution to a really big pollution problem was just planting some grass? Seriously, what if just by turning a cornfield into a pasture, you could kickstart this amazing natural process that actually cleans our drinking water? Well, that's exactly what we're going to dig into.
All right, so to really get what's going on here, we have to look at this like a tale of two very different fields. On one side, you've got your typical conventional crop field, and on the other, the humble grazing pasture.
So, you might be wondering, why would a farmer even make this switch in the first place? Well, a lot of the time it just comes down to plain old economics. Think about it. A university study found that when crop prices are down and the cost of everything, fertilizer, equipment, is way up, it can actually be more profitable to just let cattle graze. And it's this simple business decision that, kind of by accident, sets the stage for this amazing environmental discovery.
And that brings us to Wisconsin. We're talking about an area with really sandy soil, which means the groundwater is super vulnerable to pollution. So, scientists did this comparison. They looked at the water under a regular cornfield and then compared it to the water under a few different pastures where cattle were grazing. They just wanted to answer one question. What is really going on down there under the surface?
And what they found? Well, it wasn't just a simple difference. It was more like a puzzle. A set of clues that all pointed to this incredibly powerful natural process that was hard at work.
Okay, so clue number one was pretty alarming. The data was crystal clear. The groundwater under the cornfield was loaded with nitrate pollution. The stuff that comes from fertilizers. But then they looked under the pasture, and the nitrate levels were just gone. Dramatically lower. A huge difference.
And we're not talking about a small difference here. The nitrate level under the cornfield was consistently over 10 milligrams per liter. Now, to put that in perspective, that's above the federal safety limit for drinking water. So for any community that relies on well water, this is a really, really big deal. All right, clue number two is where things get really interesting and a little weird. The water under the pasture was full of something called dissolved organic carbon. Just think of it like high-energy fuel, coming from all the decaying plant roots and manure. But here's the strange part. At the same time, that water was super low on oxygen. So, something down there was burning through all that fuel and using up all the oxygen. Okay, so let's recap the clues. We have a pollutant, nitrate, that's just vanishing. And we have this weird water chemistry. Tons of carbon fuel, but almost no oxygen. Both of these clues point to one incredible, all-natural solution. And here's the hero of our story. It's a process called denitrification. Basically, you've got these tiny, naturally occurring microbes that are already in the soil. And what do? They essentially eat nitrate pollution. They take this harmful stuff and transform it into completely harmless nitrogen gas. The same stuff that makes up like 78% of the air we're breathing right now. So how does this actually work? Well, think of it like a recipe with three key ingredients. First, you need the pollution itself, the nitrate. Second, the microbes need fuel to do their work, and that's the dissolved organic carbon we talked about. And third, this is the key, you need a low oxygen environment. Because when there's not much oxygen around, these microbes start to breathe the nitrate instead. And that chemical reaction is what turns the bad stuff into harmless nitrogen gas. And boom, just like that, the water gets cleaned up. Okay, so this brings us right back to our tale of two fields. Why was this amazing underground cleanup crew going full steam under the pasture, but was basically MIA under the cornfield? Honestly, the researchers from that Wisconsin study summed it up perfectly. They found that a huge amount of the nitrate was being turned into harmless gas under the pasture. But that just wasn't happening at the corn site. Why? Because the cornfield was missing a crucial ingredient, a big enough supply of that carbon fuel to get the reaction going. The pasture with its grasses and manure created the perfect recipe for this whole process to just take off.
All right, let's break this down visually. First up, the problem itself, nitrate pollution. Look at that. It's through the roof under the cornfield, but barely there under the pasture. Next, let's look at the fuel, that dissolved organic carbon. You can see the cornfield is basically running on empty, while the pasture has a full tank. And finally, here's the payoff, the result. The cleanup success rate under the pasture is huge. That natural filter is just running at full power. Meanwhile, under the cornfield, the whole process can't even get off the ground.
So this is more than just a cool piece of science, right? This discovery has massive implications for how we think about everything, from farming and conservation to securing clean water for the future.
So if there's one thing to take away from all this, it's this. Those perennial grasses you see in a pasture, their deep, dense roots, plus all the organic stuff from the grazing animals, they create the absolute perfect conditions underground. They build this carbon-rich, low-oxygen zone that literally turns the ground into a powerful, self-cleaning water filter.
And that really leaves us with a pretty powerful question, doesn't it? In our constant search for all these high-tech, complicated solutions to pollution, could the future of cleaner water have been hiding right under our feet this whole time, just quietly working away beneath the grass?